Hello, welcome, good afternoon. My name is Laura Webb. I'm a project manager at Duke University and the shepherd of this NC Share project. You have found yourself in the room of the NC Share Research Computing Peer Demo. We are so delighted you are here. I'll just give a little bit of context setting for the time that we'll have together. We are recording and it will be shareable at the end of our session. Please visit ncshare.org to see it afterwards. We'll have about 20 minutes, 25, 30 of demos, which will be uninterrupted time from our presenters that you can hear more about what they are doing with the tools that we have to share with you today. There'll be a little bit of a moderated Q&A with them during that time, and then we'll have the bulk of the session at the end to answer your questions in an open forum. Feel free to use the chat as they go. We'll be interacting with that throughout the whole session, and we're here to answer any questions you have. Thanks for being here. Tracy Futhi, can I hand it over to you?
Thanks, Laura. Welcome, everyone. Glad to see you all here and glad to know of your interest in this project, which, as you can tell from the introductory video, we're very excited about. We have some colleagues here joining us from Duke University who have used exactly the kind of environment that the NC Share project would make available to your institution. So we're excited to move just briefly to let you know those of us involved in helping to deliver the project, and then move to the real main event, which is hearing from your faculty colleagues who are actually using and doing this. Let me just mention and ask each of my co-PIs. I'm the PI on the grant, by the way, Tracy Futhi from Duke University, Chief Information Officer here. Charlie Neifel, can you introduce yourself?
Hi, I'm Charlie Neifel. I'm CTO and Senior Technical Director in OIT, and I'm the PI on the second grant for this process. Kevin?
Charlie is helping to create the environment along with colleagues at MCNC. Kevin Davis, can you introduce yourself?
Good afternoon, everyone. Kevin Davis. I'm Chief Information Officer at Davidson College and co-PI on both grants.
And we have two other co-PIs who could not be here. Let me mention their names to you. Tracy Dokes is the president and CEO of MCNC, the research and education network we use here in North Carolina. They are an essential partner in delivering this project at scale to your institutions. And likewise, Leah Kraus is the CIO at NCCU, North Carolina Central University. She joins us as a counterpart to Kevin, helping to pilot this at her institution before we bring it out to the rest of you. So with that, let me introduce and pass this along to our fifth co-PI in the project, Professor Deepak Kumar from NCCU. Professor Kumar.
Thank you, Tracy. Good afternoon, everyone. My name is Deepak Kumar, and I am the Interim Associate Provost and Dean of Research at NCCU. I'm also a health disparities researcher, and this project is really very important because not only as an administrator and in terms of enhancing research and teaching at NCCU, but also to engage researchers in this high performance computing and the shared infrastructure that NC Share will develop. My own research, I'm a basic scientist, I'm a cancer biologist, and my research evolves around signal transduction, identifying molecular markers, and my research revolves around gene expression studies. So one of the studies that I have is I'm trying to figure out how epigenetics and social factors interplay with each other in terms of people who live in different social environments, how that affects epigenetics and gene expression in these individuals and the disease processes. And in that process, we generate a lot of data. And oftentimes, we don't have the tools and expertise and ability to share the data with our colleagues. So this kind of infrastructure would be very useful. Also, if you want to engage students, I think this infrastructure would be very useful for researchers like me and other NCCU researchers and other partner institutions. The other side of spectrum is that my research also includes some of the translational work. So, for example, we did a vaccine hesitancy study during COVID, and we created we gathered large amount of data, survey data from individuals on vaccine hesitancy, impact of COVID, from the communities. And again, how do you interrogate such large amount of data in a meaningful manner? and how do you share that data? So I think this platform will really help us a lot in working with our colleagues at MCNC, Duke, and Davidson. I mean, I think this would be very useful for us. So we have 2 sessions planned today, and with that, I will pass it on to Dr. Stephens Martinez, who's going to talk about Introduction to Jupyter Notebooks and how we can utilize that. So, Kristen.
Hello. So I am Kristen Stephens Martinez. I'm a professor of the practice here at Duke in the computer science department. And so that means I focus on teaching, and I mainly use Jupyter Notebooks for my data science classes. So let me share my screen real quick. There we go. All right. I, of course, lost now the video feed of all of you. Just give me a second to refine that. There we go. Okay. So I've lost my notes. There it is. All righty. So when I asked what kind of audience you all were, I kind of got you were all a mixed bag of different things. So I'm going to try and show you all how I both use Jupyter Notebooks for my teaching as well as my research. So I do research in computer science education, and my students often use Jupyter Notebooks to do research in. So to me, Jupyter Notebooks are a very powerful tool because you can see the results of like small chunks of code without rerunning all of the code, which is useful if you have like a bunch of stuff that analyzes the data and then you're like over and over again trying to plot it. And so you like tweak the code a little bit, you rerun it so you can see the graph, and then you realize the graph's not quite what you wanted. And so you can tweak it again and run it again without having to reprocess everything, which is super useful. Notebooks are also useful for adding some like nicely formatted text that you can use to write right next to the code and the results. So it's easier sometimes for my students to kind of explain what they're doing because everything is one single file. And then if you're teaching, there are autograders available that you can use. And one autograder, the main autograder that I use called Otter, is both. You can generate a notebook that has the tests embedded inside of it. So you don't need an internet connection or anything potentially. And then the students can run just in their notebook to find out if they're right or wrong. Alternatively, we often use Gradescope as well, where you upload to Gradescope, and Gradescope is a service on the online where it'll run your autograder for you and then also report back grades. At Duke here, we have everything kind of integrated together. So Gradescope and our learning management system talk to each other, and you can transfer grades between them pretty easily, which is nice. So in terms of demos, I'm going to give you 3 demos to kind of show you the breadth of what's available. So for lessons, we have a lesson, for example, this lab here, which basically, if you wanted to write a lab for students where everything's in one single screen and file, they're not tabbing around or going to different windows, you can literally write whatever you want, saying like, welcome to lab 2, we're going to learn more about Python. And this is a number, run this cell to find out what happens when you run this cell with a number. You can even, if we scroll down a little farther, have it, there's different pictures embedded as well. You can embed pictures. You even can run and have a YouTube video play inside of the notebook. If, for example, this was a, say, flipped class where students, or you want students at home to go through the notebook, they can run YouTube videos in their screen, so they don't even have to go anywhere else for that as well. And then in terms of exploration, so for example, let's see, embedded grading, that's the next thing I wanted to say. Okay, sorry about that, embedded grading. So here is a worked example worksheet that I have my students do in lecture. And for this, what we can do is, let's say I had the students answer this first question where I tell them, find the value at row index 2 and column index 1. So I'm having them practice indexing within pandas. I'm going to quickly go over here and grab my cheat sheet of what the answer is for this, so I don't have to remember it off the top of my head myself. And they can type, let's say they type in their answer, right here. They run that, so we can confirm that Q1 is the number 7. And then we run greater check. Well, first we have to run it, so we actually have greater check inside. It'll show that they passed that particular test right in the browser. I mean, sorry, not in the browser, in the notebook. So then if we, for example, just gave them, they finished all the answers. One thing that I kind of like is that if they had all the answers and they ran that, it'll tell them Q1 pass. So you passed all the questions in there, and the little emoji actually changes each time they run it, which is kind of fun. Other things, exploration, revise, and rerun code. So as you can see, I could run this cell over and over again. So for example, I don't have it in here so much, but let's say that you didn't quite like this graph that's here. So you could instead say, I want this to be a line plot for some reason. This is one of those cases where since I'm not running all of my cells, things are not quite working. There we go. I want it to be a line plot instead. So there we go. We can have a line plot as opposed to the histogram that was before, and I can run the cell as many times as I want to find out and play around with the visualization, for example. And then last but not least, another thing that's nice, as I was mentioning before, for data reports. So you can, students can put everything in one file and explain what they're doing. And an example of that is this notebook that is actually on GitHub. So if you use GitHub, GitHub renders notebooks just fine or reasonably well. And this one is a report that my grad TA runs for me every week about how office hours are going. So it has embedded graphs. It tells me exactly how many students are showing up to Zoom helper hours or in-person helper hours versus grad TA helper hours or office hours. He has a whole section on like how things are going overall, how things are going for this week. And I can kind of consume this very reasonably quickly and see, okay, so it looks like module 3 was the hardest module, but module 4 was not that far behind as we're slowly progressing our way through this semester. So back to my slides. So when you're using notebooks, especially if you're teaching with notebooks, there are a couple potholes that you have to be careful of. So for example, the biggest one that I've seen students get in trouble with is cells can be run in any order. And as you saw when I was doing my demo, I was running cells out of order and skipping around. And sometimes that screwed up because then the library in the backend wasn't actually available yet because I hadn't run it. So here is actually a question that I give my students in lecture to really hammer this in, that like, tell me, what do you think is going to be printed given that this is what the notebook looks like? Most of them, unsurprisingly, don't get these questions right because they're still learning how notebooks work. And so the answer for both of these is that this one, print X, is to a certain extent unknown. Like you don't know what it could print, because even though this says 5, you could remove what is available here and you won't actually know if this cell was run. And in this one, students often think that this will print an error, but since this cell was run and this number here says this cell was run, A and B are both available. So this will print the number 3. The mental model that I give my students to help them understand these things is the number here, this is input, and then it has this little output. And it's almost as if when you run a cell, Python takes all of that code and pastes it into a Python interpreter in the backend. And that number you see is the number of times Python is pasted into the interpreter in the backend. Not account for that cell, but just kind of general, it's counting the number of times it took the contents of a cell and pasted into the interpreter. This means that if I change this cell, it's happily going to do everything it's going to do, but clearly it's not going to have like backtracked and pasted that, whatever that cell was in before. So students often, I tell students often that you need to do a restart of your whole notebook if you are trying to debug and you don't know what's going on, because they could have like screwed up what's happening in the back end. And this is just kind of more of a, as I said, it's a pothole, but if you're aware of the pothole, and on top of that, you just have some good like hygiene practices where you always start at the top, restart the kernel and go from the top to the bottom. You won't actually hit any of these potholes, but if you're jumping around, you might screw up. So for those especially that are teaching, I thought that would be useful to know. The other part that is good to know about, both for if you're using these notebooks for research or you're using these notebooks for teaching, is that server utilization is hard. It's hard to understand how hard the servers are going to get hit. Because, for example, when I was using these for my introductory data science class, so these are students who've never coded before, and I was giving them really large data sets. And so sometimes they would do things that would just grind the servers to a halt because they're doing a crazy thing with a large data set, and then they're doing something like triple nested loops, which makes no sense and is just hammering the notebook a lot. And so if, for example, you're doing an exam, and I actually did an in-person exam on Jupyter notebooks, like we had a room that was big enough, and this is pre-COVID. And so we were all right across the edge of the room. So no one could really quite shoulder surface easily without being obvious about it. And I was so glad that we did a dry run with the practice exam the class before, because that's when we discovered that I needed to warn IT that we were going to do this big hit on the servers, because all the students in that moment are going to hit the servers at once, because they're all, working on their particular exam, and the data set's like reasonably large for their exam, that them all running kind of the same thing at once was going to peak the utilization more than normal. In terms of how I teach with notebooks, I have a couple different, I have two different classes that I use. One is my intro course, as I mentioned before, and I'll share a link into the chat after my demos, my talk. So the weekly cadence is that it's a flipped grouped work class. So they watch videos at home, they take some reading quizzes, and then in class is applied active learning in classes with groups. And they're all submitting a notebook individually, but they're kind of expected to sit together in their group and work through the notebook kind of at the same time. I very much discourage divide and conquer. Well, they'll divide up the notebook and then share answers. I discourage them from doing that. And since they're working on it in class, usually I'm able to make sure that that's what is happening. And then this utilization is not as bad then, because often they're shoulder surfing into their group. So they're watching one person running the cell often, and they're not all hitting it at once. The class then also has two bigger assignments that span multiple weeks of content. That one they're submitting as a group, and they're also working on it at home. And then they have a final group project with their own data set. For my intermediate data science class, I also, I assume that students know how to code, but they don't know statistics. So we're teaching them slightly different material. And the weekly cadence is basically all individual work. And I actually use the servers for this class as a more backup, because for this level of class, the students are kind of expected to know how to install Jupyter notebooks on their own machine, but the servers are really useful as a backup, because there's always at least one student who says, my laptop broke. And I'm like, great, you can use the servers anyway. So you're not going to miss homework, you're not going to miss class or anything. And if all else fails, you can go to the library and use the servers and log in that way, rather than having to rely on your own machine. For using notebooks in general, they're mainly used as worksheets and homework. I showed you the worked examples. I also have homeworks that they submit to Gradescope, and they're auto-graded on Gradescope instead, so that I have a bit more control on whether or not they can see if what number the test is looking for. Because often I'm checking for things like calculate the p-value of this, and then it's going to check if the p-value is in some certain tolerance. And I don't want them to know that I'm looking for a p-value of 0.117 or something like that. So it's a little easier to control that by having them go to Gradescope to submit their work there. So, and let's see, I think that is my last slide. And I will put in the chat the links that I have on my slides, and also a link to my slide itself. So if anyone wants to use that, they are welcome to do so. And with that,
Thank
I
you,
will
Kristen.
stop sharing.
Thank you, Kristen. I think this was great, and we do have time for questions from the audience. But I do have a couple of questions that I wanted to ask. The first one is, from the teaching perspective, where do we start? I mean, this seems like a lot, but how do we start in terms of incorporating these notebooks into our courses?
So I think, like, in my opinion, it kind of depends on what your goals are. Like, are you adding the notebook into the class as kind of like this extra activity, or do you want the students to really robustly be able to use them? If you're that, like, because if you want to use, like, robustly use them, then you're revamping and recreating like a whole new class, and that's one thing. If you're just kind of like, we're going to try this out and see how it goes, then I'd say start small. Like, say, create a notebook that the students kind of have a more structured, these are the steps you're going to go through. You're not necessarily going to expect them to go off and, go find your own data set and download it and upload it into the servers and do whatever. You're not going to have them do any of that kind of thing, in my opinion. You start small, work your way through, slowly adding more notebooks or adding more things as you go along, rather than, like, unless you have a whole month in the summer to build from the ground up of what you're going to do with the notebooks.
And so thank you. And from researchers' perspective, I mean, sometimes you already have the code to process your data. And so how do you incorporate that into the notebook? Yeah,
so for that, like, if you have a lot of code already, like, you definitely don't want to put that in a notebook. Notebook in some ways is not the greatest on GitHub or whatever you have for repository for version control of your code, in my opinion. Instead, you just need to package it up so that you can import your various code and functions as libraries into your notebook. And that way, it's actually best practice to not have a whole lot of code in your notebook. You want it in regular old Python library files, and then you call it as necessary. And there's ways to integrate the two together in a seamless way.
Got it. Well, thank you so much for that. And with that, we move on to the next presentation, which is by Dr. Minay Sitting-Kaya-Rendell. I am sorry if I messed up your name, Minay, and Colin Rendell.
No worries. Thank you very much. I'm Mina Rendell. I am a faculty member in the Department of Statistical Science at Duke University, and joining me is Colin Rendell. We are going to demo for you. The demo specifically is from the same container that we're going to demo. We want to demo things from the same environment. That's why we're sort of sitting together here. So I am going to start by sharing my screen and also providing a little bit of background. So I primarily teach undergraduate courses, and the demo that I'm going to do for you is for an undergraduate introductory data science course. And let me go ahead and drop the URL to the course page from last semester. So if you would like to sort of browse around later, you can do so. And let's go ahead and share the screen. And so the toolbox for this course is students are coding, learning to program in R, and also doing so in RStudio. They're writing in computational documents using Quarto, and I'll show that to you in a second. And they are also learning version control and how to use Git and GitHub. So we distribute everything as a GitHub repository to them, each of their assignments. And when it's time for them to do anything, that is work on homework, work on an exam, or come to class and work on some hands-on exercises, this is the webpage that they go to begin with. So this is the webpage that our IT folks who are all on the call here have set up for us. And at the beginning of the semester, we have them reserve a container. So this particular container, Stat 199, is the course I was teaching. And that's sort of what it looks like on the inside. It's basically an RStudio window in the browser. And what we also give them is a repository where they can grab starter files from. So this is the repository. Let's assume I'm a student and my instructor has put together this repository for me. So I can go ahead and copy the URL for the repo, and then I can go to RStudio and I can say, give me a new project. And we're going to say that we want this project from version control from Git. And then at this point, just copy the name of the URL of the project here. And what's happening at this point is our studio is sort of grabbing all of the files. You may have realized, perhaps to the keen eye, this is a public repository. That's obviously not how we do things for student work. We create private repositories. We walk them through how to authenticate for Git. I'm going to set those details aside for a second and sort of give you a modified version of their experience. But this is exactly what day one looks like. So what I'd like you to think about is close your eyes for a second and imagine you're not teaching data science, but you are teaching baking. And you're going to teach people how to bake cookies. You have two options. You can ask them, drop them in a kitchen where they have to build the kitchen first and then do the cooking, or you can bring them into an impeccably, designed kitchen that's ready for baking with all the mise en place. I think we can all agree we can sort of we would all like to teach in the second version, and that's basically what this is. They authenticate with their Duke IDs here. So it's something they're familiar with, and they are immediately in a computing environment. So then we talk to them a little bit about, so unlike Kristen using Jupyter notebooks, we are using Quarto documents, but these things are sort of in essence, are very similar. Some prose and then some code chunks that can be ran individually, or they can be rendered as a whole. So one of the first things that we ask students to do is, don't worry about what's in the document. Go ahead and render the document itself, and let's start playing with some data. So in this particular case, we're bringing them some data from on how countries vote in the United Nations since the early 1900s. And the analysis that they're doing on day one, obviously they have no idea what any of this sort of code means, but that's okay. They can scroll down and start looking at sort of the visualizations that are created for them. So we get to talk a little bit about how have these three countries that I have sort of semi-arbitrarily selected here have voted in the United Nations over time. How have their opinions been similar, and how have they been different? So we are able to get to the first visualization of their very first introductory data science course. For a huge percentage of them, their first computing experience. We're basically at 4 minutes and counting here. So that's, I think, a pretty neat thing to be able to do. Now, obviously, there's a lot happening in this document, and we might want to, start walking them through it. We're probably not going to be able to teach all of the code here. And to give you all an idea, by about week 5 of the class, they're expected to be able to write this code. So the goal for day one is not that. But one thing we asked them to do on day one is to say, make this visualization your own. So take out one of the countries we have plotted and pick another country. And without any instruction, students are able to figure out where the country names are, and then maybe change this to a different country. And they know that the only button they need to push now is render. And so they are able to generate their own individualized, sort of personalized visualization and start talking about the results sort of on the spot. One of the nice things about these computational documents, these Quarto documents, is, here we go, we have a new visualization that they have made, and we're roughly around minute 5 now. So I think this is very satisfying for them to be able to say that. And one of the ways we've been able to do this is, obviously, we've dropped them into these containers where our studio and R are already installed. But also, for those of you who might be R users, this code chunk might seem familiar. We're using a bunch of R packages. These are pre-installed for them as well on the container. So we didn't have to wait on sort of package installation either. And I, as an instructor, sort of decide at the beginning of the semester which suite of packages I want to give to them. A nice thing about our studio is, and using these Quarto documents, is that the editing experience is very familiar to them. Things they know about bolding, italicizing, and whatnot, all work. Keyboard shortcuts work. And in fact, a lot of our students, I find nowadays, take notes and things where they'll use keyboard shortcuts to enter sort of maybe not code chunks, but maybe to-do items or something, and the interface is very familiar to them. However, a nice thing is, if we switch over to the source editor, this is all plain text. So they are able to actually write in plain text without realizing so, which we'll reveal to them a bit later in the class. which means that they are able to sort of see the changes that they have made as a Git diff and push their changes immediately to their GitHub repositories as well. So the day-to-day experience feels like I'm in Google Docs, but really I am writing in plain text and I am writing code. I'll head things over to Colin now.
Hi, all. My name is Colin Rendell. I also am in the statistical science department at Duke, and a lot of my teaching is also around statistical programming, but mostly at sort of the senior undergraduate and master's level. And we use exactly the same toolkits and the same tools in those courses that we do in the introductory one. And there's a large power to having sort of that tool grow with the students as they progress through our curriculums. They learn it in the first class, they see it in their second class and their third class, and they just keep building on those skills as they go. And these things scale very nicely with them as they do it. So just a couple of things that I'll also point out about this environment that we sort of get for free by working here is, what do we do when the students have finished their work? So Mina was able to render the document before, and for the default settings that we have, this is currently rendering to an HTML document. The students can download that document and then upload it to your course management site. Your TAs can grab that, and that's what they can then grade. If you're using a tool like Gradescope, Gradescope doesn't speak HTML, it only uses PDFs. So by changing one thing in the front matter here, I can now take this document and render it out to a PDF. It will use LaTeX behind the scenes, but the nice thing is I never have to tell my students the word LaTeX. They can just render the document and they will get a PDF that they can do exactly the same thing. So they can then upload that to Gradescope and we can use that for grading. And so this continues to scale in that way for all sorts of different tools. One other really cool thing with RStudio now is the name might imply it's R focused, but they spent a huge amount of effort extending it to use a bunch of other tools. So I can do import NumPy as NP. X is equal to NP linear space 0 to 2 times pi, like 100 steps. And Y is just going to be NP sine of X. So this is a notebook file that includes both R code and Python code. I can run both of them. I can render it. Nothing changes as my experience as a student. It all just flows seamlessly. And I screwed up something, so it's not finding my Python install. So that's my fault. We tried this before, the danger of live demos, but it is entirely possible to set these all things up so that all of these things work very nicely together in an environment and then run smoothly so that you can move back and forth between these things. So if you teach a Python course, they can use the same environment as with an R course and vice versa, or mix and match where they're using whatever's the best tool for the particular job as they go. So I'll leave it there and we can open it up for questions.
Well, thank you, Colin and Mina, for that explanation. So again, we do have time for a question from audience, but I do have a couple of questions I wanted to ask. You talked about getting materials from containers into the containers. So what are other options for getting these starter material into the student containers?
So the example I gave was getting it from GitHub, which works really nicely if teaching Git and GitHub is part of your learning goals. And I think a complete overkill if that's not the case. So we use the same setup for our introductory statistics courses as well, where version control is not part of the learning goals, but using R and RStudio R. And in those cases, we have sort of done two things. Either the instructor can post that starter file, the original Quarto file that I had, on their course management system, and then the students can actually download the file. And once they do, you'll be able to see here, they can actually upload files in here. So you can sort of on the fly deliver files to your students and they can upload them into the container and then sort of work with it. Alternatively, if you are the kind of instructor who is prepared enough, you can have all of your sort of handouts, if you will, ready at the beginning of the semester, and they can be sort of be available for your course at the beginning of the semester. You've seen at the very beginning, I had you on a page where I selected my course's specific container. So I can have a set of documents for my course. Colin could be teaching something entirely different, and he can have a different setup for his, and we're not polluting each other's course environments.
And the same goes for data sets and other kinds of ancillary files that you might need. They can come from GitHub. They can be downloaded from the web. You can pre-populate the containers. Any of these things are options to move those things in. And particularly for large data sets, then you can have one shared resource and the students are all not keeping their own copy locally, which is a very nice thing.
And how do you decide which packages and libraries a course might need? I guess it depends on the data set, or
Yeah, it ultimately depends on your learning goals for the course. And I will say that, you know, depending on the learning goals and also honestly your teaching style, you might have a pretty sort of stable list at the beginning of the semester. If you're a little bit more of an adventurous instructor and, you know, you're reading some cool blog post over the weekend and you're thinking, could I teach this tomorrow? Well, you can, because ultimately students can install those packages. So the thing is, we're not limiting which packages students can use in this environment. We just have a set of packages that we can count on working on day one. And I think if you're kind to your IT professional, they might do a little update for you. And I think the nice thing there is the fact that you have these course sort of containers separated. So, you know, if my request would potentially negatively affect a colleague's course, that would be a big no. But at least with enough lead time, I can decide for myself when I could afford a little bit of a few hours of downtime and when I might be able to borrow some time from the IT folks to be able to update things for me.
and is there any value to students in installing R or R Studio on their own laptops? And when is a good time to introduce it?
So that is valuable. We want students to not be dependent on our infrastructure to be able to do things. But as somebody who, when the first time I taught a statistical computing course, had them installed on their laptops, debugging 30 students, let alone 200 students, individual technical issues when there's a problem is a nightmare. So the value is get them on board, get them doing stuff very, very quickly. Containers are fabulous for that. And then over the course of a semester towards the end, like, yes, encourage them to install it locally to try it. If they run into an issue individually, they can come in to office hours or some other time where they can get technical support. You can carve out specific time for that. But you're not then all being slammed at the same time with it. Similarly, you know that there's a backup. So just like Kristen said, there's something that will always be working, that it's not going to block them from doing their assignment at any given point. And that's really, really valuable to have. And so that's what's really important there.
And the other thing I'll add there is, as an instructor, if you are having them install things, you need to be able to feel confident that you can sort of troubleshoot things. And, you know, I work on a Mac, for example, and I can pretty well troubleshoot things there, but sometimes I can't on a Windows machine. And it's really difficult situation to be in when you can have help half your students and not others. Sometimes students have operating systems in a different natural language that can be really difficult to debug. And I think ultimately there's an equity issue to be made. If I am giving an assignment that's potentially computationally intensive and one student has a much faster computer than the other, now they are getting to blow through that or at least iterate through that faster. And that to me is, I think, a big no-no. So with this setup, students could have a Chromebook, which can be quite cheap, and still have access to sort of both the file system and sort of top-notch computational resources, which is really nice.
Wonderful, thank you. And at this time, I guess, Laura, we can open up for the question from audience.
That's right. Feel free to unmute or post a question in the chat.
Hey, Laura, if I could just chime in with sort of a public service announcement, and that is to say, we're talking today about two specific kinds of containers, one for Jupyter notebooks and sort of programming environments, and another for our studio. And the reality is at Duke and in the environment we've built and in the environment we imagine for NC Share, there could be scores or hundreds of different kinds of containers, each reflecting a different kind of package. And this all goes to the point that we just heard from Mina and Colin, and that Kristen chimed in the chat. Trying to debug that on individual installs is really problematic. So if we can create these environments on your behalf and make them available, it's a huge benefit. What we demoed today, as I said, are two of those. But it would be also interesting to hear from all of you, what are the environments that you teach in that could be interesting for us to consider down the road.
Any other comments, questions? I think this was really helpful. And can we reach out to you if you have any, if any of us have any questions? Both the teams. Wonderful.
And I would just add that I know Mark has built an IDE, an integrated development environment called Eclipse for computer science, because they also found that they were losing the first week of class trying to get all of the students configure and install the IDE, the Eclipse IDE, and some students never got it to work. Whereas with having it in the container, they were all available on the first day, and then I think it was about half of the students seem to have migrated to doing it on their own by the end of the first semester.
I'll also just chime in briefly. I think this idea of the containerization of tools and making them accessible from the web is an incredibly powerful idea, because it's even for software that's proprietary. So like MATLAB or ArcGIS, and I'm not sure what the current state of affairs of our containers are for those kind of things, but these are things that students used to have to go to a computer lab or go to the library to get access to. And so they're very limited in time and scope where they could do that. And now they can access it from the classroom, from their home, if they're traveling, any of those kinds of things. All you need is a web browser. You need a reasonably good internet connection to do it. But beyond that, it just opens up the accessibility so much more for a bunch of these tools. That's really a profound thing for both teaching as well as the students. So I think it's really important.
Thank you. And Christian, do you have a day for InstallFest?
So for us, InstallFest kind of spans multiple days. And we often pull TAs across, undergrad TAs from across courses, because a bunch of different courses have different installation requirements, unsurprisingly. And so we will, and this is often actually with OIT. OIT often provides people as well during these InstallFests. I think OIT is the main person that organizes it, and then we contribute some of our TAs to help out. And it's like a couple of days for a certain number of hours during the first and second week of class.
I might also add that I would encourage folks to not think of the containers so much as training wheels. It is true that they're very helpful as training wheels, but I think, you know, in an industry setting, for example, the most advanced of analyses are also being done not on your computer. Also, if you're working with research data, probably you don't have it on your computer. So it's really nice. Turns out it's like this thing where, yes, students should learn how to install things, because like that as a piece of knowledge is an important thing in your training. But in practice, the likelihood of, you know, our students just running code on their computers is actually pretty low. I feel like among sort of my colleagues and friends, if they're academics, they do that, but pretty much otherwise. And unless like they're working on sort of if they're not working on sort of human data, maybe they do that. But in much of industry, a lot of the compute is happening on somebody else's server anyway. So it is actually a realistic experience for them.
So I think if there are no more questions, Laura, we can go to the next stage. I just wanted to thank again both the teams. And I mean, one of the goals of this grant is to create this community of practice, which we have started today. And we do hope that we will expand this, include other researchers, and have more sessions to create this community where we can exchange ideas and help each other out using the NC Share infrastructure. So thank you all. Laura, on to you.
Professor Kumar, before we go to the next stage, I just saw a chat from Mark McCahill he's a member of the Duke team, talking about over 50 containers for courses and talking about some of the kinds of environments. Mark, you used some language in here that I think might be familiar to many, but might be a foreign language to others. And
Sure.
What do you mean when you describe that things like MATLAB and other graphic user interfaces, we can embed VNC remote terminal in the web browser? What does that mean to the everyday person like me who doesn't speak VNC remote terminal?
Tracy, I knew you were going to call me out on this. What we can do is take a graphic user interface, something that's assuming that there's a mouse and overlapping windows and that sort of thing run on a Linux server, and embed that inside of a web browser. So we can do a remote terminal access to a Linux environment that's one of these graphics user interface environments. It's using a remote terminal protocol, but embedded in the web browser. So there's nothing to install. That makes it possible to do stuff like MATLAB and all sorts of fancy Linux GUI graphic user interfaces without having the students install anything. It works surprisingly well, assuming you have a reasonably fast internet connection. So that's part of how we got to like 50 of these things. It's not just RStudio and Jupyter Lab, although those are the most popular. There's a bunch of other smaller players that we do.
So I'm able to use not just the computational power of that remote machine, but also its graphical interface, so to speak. So
Yeah.
if I don't have a fancy machine that would normally render those graphics, I can do that anyway using the remote environment in the container.
Yeah. For a lot of the Linux graphic user interface, they're using an environment called X Windows, and we can support that inside of the web browser, if you know about what X Windows is. Mostly it's useful for doing some of these strange, hard to install on your Mac things or hard to install on your Windows machine.
And Mark, how do we start? I mean, how do we gain access to this? What's the process for institutions outside too?
Well, that's actually a Laura and Tracy kind of question, but for building the containers, which is more my thing, we typically start with a kind of working instance and then just work with the faculty member to make sure that it's got the right packages and does the right things. Something that Mina and Colin didn't mention, but take advantage of, is instructors who can update the container definition during the course. You don't have to come to me, and they don't. They go and do it themselves. So for the faculty who are comfortable with that kind of thing, we've set things up to automate the building of the containers so that they can update at 1 in the morning when they feel like it, which is certain people's style.
And Mark, this also means we kind of relieve what used to be, at least at Duke, a constraint we had, that the first day of the semester, we would lock down the way that public computer lab looked because it needed to be identical for everybody all the way through the semester, because we couldn't afford a time when a package got upgraded and broke something else. And so that obviates the need for that kind of lockdown world. And Colin can decide to update his environment every other day, whereas Mina decides she wants to keep hers consistent and different looking.
Yeah, the thing that also makes it a little bit more safe to do is, since we're doing these builds using Git repository, if you do something and it breaks, roll back to the previous version and deploy that. And since we've automated the deploys, it's possible to bail out on a change at 1 a.m. that doesn't work out so well and go back to the previous instance. So getting started, I'm not in the getting started part for joining the NC Share project, but for getting started with building the containers, basically we'd start from something that's kind of in the ballpark and then just work with the instructor on what makes sense, what do you want to have in the container, and then set them up so that they can start managing it themselves, or the IT staff can help them manage it if you want to do that, if you want the control of change stuff at 1 a.m.
Wonderful, thank you. Dr. Shalkova, you have a question?
Yes, hi, this is Natalia Shalkova from Guilford College. I have a question, not from, I guess, from a teacher, but from a researcher. And I'm an economist, so I'm not in statistics. And I know my colleagues know R and Python. I have basic knowledge of Python. As a researcher, I'm using Stata. That's what we use in economics. So is it possible to, or do you have Stata pre-installed so that we can use remotely? So that's one part of my question as a researcher, and then I can continue with my non-research question.
We haven't containerized Stata, but it's partly because of licensing issues around it more than not technically feasible to do it. So there has not been enough of a push for someone to say we really need it, but it's technically feasible.
Okay, and we also have colleagues who work with SPSS. I know in psychology department, is that available? Do you know? And possibly SAS?
Again, if depending on the licensing, that's probably the biggest hurdle here. Packaging it inside a container is not the hard part. It's getting the licensing so that it's legit to do that. One of the advantages of R and RStudio is they don't have the kind of licensing limits that you have with things like SPSS.
And who should have that license? Is it our institution or your institution?
It's normally your institution, and what we've
Oh,
done in
our
cases where we
institution,
need MATLAB, for example, which is licensed, is it checks back in for a user based on our licensed server. So we built it so that we can enable those things when we're running these on remote locations, not inside our campus.
So Charlie, if we have State House SAS license, then we can use your license.
Well, you can use the server as long as it just comes back in and checks that it checks out one of your licenses.
Got it.
For the time.
Okay, okay.
Good question.
A related thing is Maple is one that some of the instructors here use that requires a license at our place. And again, we've containerized that and it checks against our license server to make sure we've got enough licenses for what we're trying to run.
Okay. And is it easier to check what your license allows you to do?
Probably, but sometimes you have to be a lawyer.
Right.
So I would say
I'm talking about under-resourced institutions. Maybe we have a lawyer, but it's probably not on site.
Yeah, and it may be that what we next need to do is have a conversation about what packages you need, what the people in the IT space know about the licenses, and then ask the question of, from the licensing standpoint, whether that's a legal person or a buying person, or whether it's a reasonableness question for the companies, right? At times there could be companies that would maybe look favorably on the ability to support a project like this, right? But we can't say that across the board for all of them.
Right, I understand, and I'm just thinking about how very few of us are there to create maybe reasonable amount of work for
That's right.
for other people.
Ideally, if there's something that's a need for several schools and several faculty, then the idea is you create the container once, right? And we share it, even if it has to check with each individual institution about the licensing authorization.
Right. Yeah.
One advantage on SAS as a North Carolina-based company is for years it's been available at no cost for UNC system schools, and the last few years also for private colleges and universities. So there's some vendors that may be easier to work with. And I believe in the case of MATLAB, there's an open source alternative to MATLAB that's code compatible. I may be confusing that with a different package.
No, you're right, there is. It's called Octave.
Okay. And I have also a specific question, but I can ask it privately. I know we are running out of time.
Thank you. I think they have, I think both the teams have shared their contact information, and we'll be sharing that information as well. Laura, what's the next step?
Thank you.
We are at the end of our time together. Thank you for coming. We will post the recording on our website afterwards and follow up with you all with more steps of how to connect further with more opportunities for demos and other outreach.
And Laura, there's a poll open as well, just to draw people's attention to it, right?
Yes. We would love to be in touch. So however, email, website, poll, chat now, we're great to finally make your connection with you today. So we'll stop there. Please be in touch. Thanks for coming. Take care.